Okay, good afternoon, everybody. My name is Dion Borg. I'm the General Manager for CCLAS here at Datamine, based in the Brisbane office. And today we're going to talk about robotics integration with LIMS. So I'd just like to discuss just some formatting for the actual webinar. So by default, all attendees are currently muted during the session, and then I plan to use about 30 minutes or so to talk about robotics integration with LIMS, and I'll leave about 15 minutes at the end for questions. So if you have a question, please leave it until the end, and then you can raise your hand with the raise hand symbol, and then you'll be able to type your question using the chat window. And if you see a flashing icon like this, it indicates that someone has posted a chat, and you can check it out by just clicking on that icon. Okay, so here's a little bit about myself. This is an early photo of me back when I started my career in chemistry. I'm doing some titration competition at school, I think this was. I've obviously went on from there to study chemistry at university. From there, I went and actually worked at a nickel refinery in Townsville. Some of you may be familiar with Queensland Nickel. So I worked there for a period of about 10 years. And in that time, probably about 6 years or so of that time, I was actually the LIMS administrator as well. So I've actually used LIMS in a real world laboratory environment as well. And now as I've become part of Datamine, I've been working with the CCLAS product now for about 10 years, and I still do some consulting. So this is me on site with a couple of our customers at New Century Mine in northwest Queensland. So from time to time, I still do go out and do some consulting work with our customers. So if you do want to add me on LinkedIn, please, you can search for Dion Borg at LinkedIn. I'd love to connect with you. Christy will also put that in the chat, so you can just go ahead and click on that link as well. So it's before we get into robotics with LIMS, it's actually important for us to understand or know the history of our laboratories and how we've got to this point now. So if you've been around long enough, you'll probably have had to use pen and paper to report your results. I actually did at Queensland Nickel when I first arrived. We had to report our results on a piece of paper, and then the guys in from the plant would come and collect it and then modify their flows appropriately. But obviously, you can see with pen and paper, it was much slower. It was very easy for people to make calculation errors, and there was a lot of transposing of instrument data and balance data onto these sheets, and doing calculations manually. So from there, obviously, we moved on to spreadsheets, and some people actually still using spreadsheets in their laboratories today. But obviously the downside to using spreadsheets is there's no actual audit trail. And that's really important because it actually doesn't track when staff have changed data, as well as the date and time. And it actually also doesn't prevent your staff from altering results, which is obviously quite important for data integrity. There is generally with spreadsheets limited instrument integration. Sometimes we have macroed spreadsheets that are integrated with instruments to automatically pull data into the spreadsheet, but this really takes a specialist to do that in an organization. So then generally speaking, sample names are manually typed into the instrument, so this can be time consuming. And then if you don't have those macroed worksheets, to pull data from instruments, then you've got to manually record against, data into spreadsheets. And there's also no integration with balances as well. So weights need to be manually recorded into spreadsheets. So you can see here it's very easy for people to make typing errors when you're using spreadsheets. The next one is around about spreadsheets. Don't have that capability to do the automatic sample registration and the automatically of printing sample labels. So separate spreadsheets would need to be created in the past for process samples, and then obviously as you go on in your laboratory, sample analysis does change. So then there's the requirement to update these spreadsheets to make sure they reflect the need for the current analysis. And then labels would also need to be manually printed. That's time consuming. If you don't go and print labels, then it's a matter of writing sample labels onto packets and all those things. So I guess the other downside too is there generally is a large number of these uncontrolled spreadsheets that need to be stored on a network drive somewhere, whereas obviously with a LIMS system you can secure everything in a centrally stored location. I'm sure a lot of you will recognize a spreadsheet like this as a common spreadsheet that some mining laboratories have utilized in the past. Multiple tabs down the bottom and all these different results to be then that our external users outside the laboratory can look at the results and adjust flows in the plant where need be. So quality control, generally speaking, it is quite complex to deal with quality control when you're using spreadsheets. So, there's no way for you as a laboratory manager to enforce users, to make sure they're actually using the right QC standards for their sample reporting, and make sure that that is correct as well. There's no way, again, to prevent users from changing QC data. And then generally speaking, obviously, once you've got your QC data, you need to be able to analyze that statistically. So then people have gone on to create complicated spreadsheets for the statistical analysis of those QC standards, or they've actually got other QC, software that they've manually entered these QC results in, and again, you can get manually typing errors. And then also, the downside of spreadsheets, no integration with external systems. So obviously, in mine sites, you've got a lot of external systems that consume laboratory data. And having to either manually type this data into the external systems, or figure out a way to get this data in the external systems, that tends to be costly for companies. So present day laboratories, a lot of laboratories now do have LIMS systems, and as a generalized view of why laboratories use LIMS systems and the benefits of those. Generally speaking, there is time saved, so you've got improved turnaround times, better data accuracy, better quality, and transparency as well. So you've got less manual entry, and that's the whole point of a LIMS system. A LIMS system should make your job as a chemist, and a manager for that matter, easier, not harder. Okay, so obviously LIMS system will generally capture results from instruments and balances, and obviously insert the quality control into the jobs. So you're increasing your quality by having a better control on the QCs that are entered, and reviewing also that QC data as they are reported. Generally speaking, it's much easier to report data from a LIMS systems. The data is generally presented in a common format, and then can be automatically exported to any external systems. And then another thing that's important is actually standardized processes. We have a lot of customers that come to us that actually have multiple laboratories across the company, and they're essentially analyzing the same commodity type. But before LIMS systems, they were doing that slightly differently, right? So obviously what a LIMS system allows you to do is standardize those processes across the laboratory, across your laboratories for companies with these multi-labs, and you've got the, similar analysis done in each of your laboratories, and you've got confidence that. And obviously, another thing that LIMS systems bring about too, staff tend to be more proud of their work. Why? Because the quality of their data improves. The LIMS system um, uh, helps them with their data integrity. They're making less typographical errors. They're not having to go back and fix results or reanalyze their samples. And it does happen from time to time, but the whole idea of a LIMS system is to reduce that occurrence. And the QC charts are like an indication of this. Is a proof of the quality of the chemist's work, right? And one of the things that we did at Queensland Nickel, and a lot of our customers had done this as well. There's a module in CCLAS called the Statistical Process Control, or SPC. So we've put our commonly used standards up on a large screen monitor. So and that graphs your QC standards in real time. So then when they're analyzed off the instrument, you can see very quickly how your QC standards are running, and it makes the ownership of your chemist to their data, and it essentially improves the quality in the laboratory. So that leads to, obviously, fulfillment in their role, and instead of, chemists getting frustrated with dealing with multiple spreadsheets. And so now moving to the future of laboratories, where laboratories are now starting to use robotics more and more. So we are seeing a number of our customers across iron ore, platinum, nickel, zinc, and even commercial laboratories now are starting to deploy robotic systems into their laboratories, and they're using these robotic systems to automate their sample preparation and also their analytical analysis. And obviously the benefits of using robotics in your laboratory is really, the first one is improved productivity. Okay, so robots can run 24 hours a day, 7 days a week, 365 days a year, and it's that's important obviously to mine sites. They generally don't get sick if you don't if you ignore the maintenance, but obviously properly maintained piece of equipment will keep running. They don't take holidays, so generally speaking, your turnaround time is improved. And then you get improved quality. Why? Well, the samples are prepared and analyzed in the same way, in the same manner, right? So that, generally speaking, creates better reproducibility of your sample analysis. And also, lastly, improved health and safety. So obviously, if you're getting robots to do a lot of the sample preparation, your staff aren't exposed to dust, noise, and heat, and there's less manual handling injuries because your staff are not having to handle heavy weights of samples. So we're going to look at one of our iron ore customers and look at why they decided to use robotics. So it being a 24/7 laboratory, they wanted to maximize their throughput, right? So the faster they could analyze the samples, the faster they could ship out the product, the more money they can make. And I'm sure a lot of you are aware that iron ore prices have risen quite considerably since the mid 2020. And also there is staff efficiency with using robots. What we found and heard from our customers is being mine sites, they're generally in remote areas, and it's quite difficult sometimes to actually get skilled staff into these regions. So having a robotic system that can be controlled by a non-chemist was also of benefit to our customer. And what we've noticed, certainly over the past few years, we have seen our customer that there seems to be less classically trained laboratory staff in our customers' mining laboratories. So we're seeing this shift to use more and more robotic systems. So then large sample handling. So this iron ore customer typically the samples that they have to prepare were upwards, between 10 kilograms and up to 50 kilograms. So obviously this creates a large risk for users manually handling weights like that. But the actual other reason for using heavier samples is that they actually get a more representative sample for analysis. So again, they're improving their reproducibility. And the other thing that we've also noticed from customers that in the precious metal space, like platinum, the robotic systems also improves the security of these high value minerals because there's less human contact with the actual samples. So this iron ore customer had a robotic system that did sample preparation. So it did drying, crushing, milling, and splitting of samples. So after the sample was split, part of that sample moves on to the chemical analysis, and then the other part is stored just in case the sample needs to be reanalyzed. After the sample preparation, then it moves on to the sizing. So the robotic system automatically, weighs each of the size fractions for analysis. And also some of our other iron ore customers have actually used different sizing sieve stacks for different products like lumps and fines. And then from there, it moves on to the chemical analysis where the beads are automatically fused and fed into the XRF where they're analyzed for about 40 analytes. And then also there's TGA analysis that those samples are automatically weighed, read on the TGA for moisture and loss of ignition. And just going back slightly, so before the actual the bead is fused, there is a portion of the sample that's also split off as well. So in a lot of the stages of the robotic system, it is splitting off and saving samples. So samples don't have to go all the way back to the sample preparation and re-prep all those samples right from the start. So the solution, let's talk about the solution that Datamine provided to their robotic system to CCLAS EL. So the communication, so it was a two-way communication with the robotic system to CCLAS EL via text files. And a lot of you are probably wondering why text files, okay? So for security, and the main reason for this is security purposes from the robotic system. They obviously didn't want CCLAS polling their database, and actually, using text files actually makes the integration process a lot more simpler. Okay, so then we and I guess our overall view at Datamine is that we actually always strive to meet our customers' requirements with the most simple solution. So otherwise, if you're making your solution unnecessarily complicated, it just leads to more failure points. Okay, then moving on to sample registration. CCLAS automatically registers a sample from the robotic system, so our Taskman application will automatically register those samples that have been prepared by the robotic system. And then instructions are actually sent back to the robotics system to tell the robot what type of analysis it needs to do, including the QC, because obviously if you're having different sample types, you're going to require different QCs for different samples. The next one is obviously importing of data. So all the sizing, XRF, and TGA analysis, that's automatically imported into CCLAS via the Taskman and online application. And then the other thing that CCLAS does, if a sample fails QC, it then instructs the robotic system to repeat that sample analysis again. Okay, and that's where those samples that are stored and split then can be taken and prepared again and reassayed. So what were the project outcomes for this customer? So obviously the integration and control of the robotic system with a LIMS like CCLAS. So CCLAS EL was used to integrate between the robotic system and external process control systems, thereby actually controlling the sample flow and data transfer. And then obviously the quality assessment of all incoming data. So using the full power of CCLAS and its quality control system was able and available to assess incoming data and make decisions about repeat assays. And then obviously if it needs to be repeated, it's then triggered by the LIMS to repeat those samples. And then the data validation interface inside CCLAS, there was like a multi-stage and validation that was managed with inside CCLAS. It actually had 5 different validation processes with complex calculations. So that was used to aggregate data into single reporting samples. So to give you an idea of the complexity, each of those samples that were prepared by the robotic system was actually split into 8 different fractions, and each fraction is analyzed separately, and then each of those analysis had to get aggregated together, and CCLAS obviously did that with various validation processes, and that was then reported as a single cargo assay. And then obviously another important thing is the integrating to reporting systems. So as we mentioned before, it's important not only to produce results out of a LIMS system, but to be able to integrate that into the plant reporting systems, because if other areas of your mine site cannot view that data easily in their current systems, it makes the process a lot less smooth. So CCLAS automates this reporting and of this and validating of this cargo data. So so it was easy to distribute this analysis. So at Datamine, we do like forming strategic partners with our customers, and that way we can work together to help our customers achieve their business objectives. So before we end the presentation, I just want to give you a quick overview of the new version of CCLAS, version 3 that was released at the end of the year. We have some recents here that enables you, as you click your applications in CCLAS, it will save up to 10 different applications, and you can also save favorites. So by clicking on the menu, you're able to produce different favorites here. So then this is the new menu style. So you can see here, you can add groups, add items to the menu. And if you click on the favorite icon when you move back, it will actually add it to the favorites menu. This Datamine logo that you see here is really just a placeholder what we plan to do in the future is, if people are familiar with the previous version of CCLAS, the browser menu, it had a lot of KPI information here, and that's what we plan to do moving forward with CCLAS version 3. So if you do want to request a personalized demo, or you can click on the link here, and I think Christy will also put that into the chat. So if you are looking at robotics, please have a chat to us, or if you're just a new customer, and you do want to just see a demo of CCLAS, please reach out to us. So I think we'll just pause here for questions. And I apologize, I think there's been some issues with the audio, so my apologies for that. We'll see if we've got any questions here in the chat. So please do raise your hand if you have any questions. Okay, a question. Are there any unexpected outcomes you've seen for robotics implementations in laboratories? I probably have to clarify what you mean by unexpected outcomes. I think, generally speaking, obviously from what we've seen is just the maintenance of the robotic systems is obviously important to make sure that they break down. But I'm not too sure who gave out that question. But if you'd like to email it directly, we could sort of cover that off a little bit better. Unexpected extra benefits. So I think for our customers, I think generally what we've covered off, covers the full range of benefits that our customers have experienced. So from our knowledge. How many operations would you say are using Excel versus modern systems, and whether that be a LIMS or robotics? Look, a lot of the newer mine sites are still using Excel spreadsheets, and sometimes it is appropriate for them. But as they move to become a more established operation, generally speaking, that's when we see people move to LIMS system. And unfortunately, most of the times, these people that are using spreadsheets, LIMS only becomes apparent when there's issues with data integrity. That's generally when we do hear from people. So obviously, if you are one of those people still using Excel, spreadsheets, it's obviously important to look at, how important is data integrity to your organisation. So RPA, so Kumaha, do we use RPA for this robotic project? I'm not aware of the RPA, Kumar, if you can explain that a little bit further. I'm not too sure of that abbreviation. And Kumar also talks about, can we have a video of today's webinar? Yes, everyone that has registered for the webinar will receive a recording of the webinar as well. Any further questions? Okay. Anything that you'd like to add, Christy, before we finish up? Okay. Okay, everybody, thank you very much for attending. Please keep an eye out on LinkedIn, and we'll be doing more webinars over the course of the year, and we will be sending an email out after this presentation with some more details. Thank you very much, and enjoy the rest of your day.